Hello everyone, MK is here. In past two sessions, I have explained how to find the strength of electric field due to point charge, due to group of charges, and due to continuous distribution of charges. We have seen how to find electric field due to a straight charged wire. It may be finite length or of infinite length. We know how to find strength of electric field due to semicircular charged wire at the center of the wire. Even due to quadrant of the circular charged wire, we know how to find electric field strength. Let us do more today. We want to find electric field on the axis of a charged circular ring. We want to find strength of electric field when surface density of charge is given. Without wasting time, let us start. So we want to find electric field strength on the axis of a charged circular ring. Strength of electric field on the axis of a charged circular ring we want to find. This one is a charged circular ring. At a distance x from the center of the ring, we want to find the strength of electric field. The method of calculating strength of electric field due to continuous distribution I have already explained. I just remind you today, this ring some charge, whatever amount, let a charge q be given to it, so that its line density of charge becomes lambda equal to q by 2 pi r. Okay, it means charge distributed along the length, not along the surface. Wait, we'll be discussing for surface charge distribution also. So when you want to find strength of electric field at this point on the axis, we need to divide mentally, of course, into infinite number of small parts. Then due to an elemental portion, we will find the strength of electric field here, and then we will calculate strength of electric field due to whole wire by integration. The method is clear, but with this view of the charged circular ring, you might have some problem. Let me take the help of this diagram. Same diagram I have taken here. It is little bit inclined now with the vertical. I mean, vertical definition is going to be changed here. This is x-axis. We will assume horizontal direction here, and perpendicular to it will be y-axis. Now, the ring mentally divided into many parts. This is the elemental portion AB. This is carrying a charge dq on it. Due to this dq amount of charge, we find strength of electric field at the point P. What will be direction? This is positive charge, no? Due to positive charge, field will be directed this way. If we assume that this direction makes an angle theta with the x-axis, then this field has two components. One is along x-axis, the other one is along y-axis. Now, this y-axis component will not be there. Why? If you take a symmetrically opposite element of the ring, that is a dash b dash, due to that, field has the same magnitude here, because this r and this r, there is no difference. Radius is r, we have taken. This r square is r square plus x square. It is true for this case also. Same radius is there. So the distance r remains the same. So for this portion, if the strength of electric field at P, we write the strength of electric field at P due to this elemental portion as dE1, then its value is given by dq by 4 pi E0 r square. Okay, this portion is r, so it is 4 pi E0 r square, where r square is given by this relation. R square is r square plus x square. This is directed in this direction as it is shown here. It's a vector quantity dE1 directed this way. And the magnitude of dE2, that symmetrically opposite portion, has the same value. It is directed this manner. Now component of dE1 are dE1x and dE1y. Similarly, component of this portion also along x-axis, along y-axis, they have the same value. You can see the component along y-axis getting cancelled. So there will be component along x-axis only, that is dE1x or dE2x. I hope all of you have understood. So I explain once more. Here we have taken this angle theta. This is also theta. Theta vertically opposite. This is also theta. So components, this is our y-axis. It is perpendicular to x-axis. X-axis is there. It is perpendicular to that. Now dE1, component of dE1 in this direction is dE1 cos theta, and it will be directed this manner also along negative y-axis. It is dE1 sin theta. Now this dE2, its component along x-axis, dE2 cos theta, and this way dE2 sin theta. Clear? Now the values of dE1 and dE2 both are equal to magnitude wise dE1, dE2. This is r. You should remember this is r and this portion is x. So this is also r, and the value of r we have taken as r square plus x square by Pythagoras theorem. dE1, dE2, their magnitude is dq by 4 pi 0 r square, where r square given by this relation r equal to under root r square plus x. Now one thing is clear, this portion symmetrically opposite and this portion, their component along y-axis getting cancelled. It exists along x-axis only. So if we want to calculate net field at the point P, it will be along x-axis only. So E net equal to what? That is dE along x-axis, this integration. Okay, because all parts will be added over there. Every part has a symmetrically opposite portion or diametrically opposite portion, so they get cancelled. So E net is dEx, and that is integration of dE cos theta. Okay. What will be limit of integration? You are integrating over the whole thing, that whole charge will come into effect. So this is integration of dq by 4 pi E0 r square. R square means r square plus x square, and the value of cos theta is x by, what is cos theta here in this diagram? Cos theta is x by r, that is x by under root r square plus x square. Okay. So this thing is constant. E at P, E net, what we have written there, E is going to be x by 4 pi E0 r square plus x square to the power 3 by 2 into integration of dq. dq integration means over the whole thing, if you take, This dq, all these are added. You integrate or just add mentally. It will have the same value which is equal to q. This by 4 pi 0 r square plus x square to the power 3 by 2. So the value of E is equal to qx by 4 pi E0. This is the expression for electric field on the axis of charged circular ring. Now we are going to calculate the strength of electric field at the center. Strength of electric field at the point where it has maximum value. It is better to say we are going to calculate the graph of electric field versus distance from the center of the charged ring in this case. So we will be starting with the expression E equal to qx by 4 pi 0 r square plus x square, that to the power 3 by 2. X is the distance from the center. So let us analyze some cases over there. That when x equal to 0, what is the value of E? E is going to be equal to 0. Okay. If the distance x is very close, when x is much smaller than r, the radius, then what will be the strength of electric field? X is very smaller than r. So this time we can write that r square plus x square is approximately equal to r square, because x is very small in compared to r. So E going to be what? E is going to be equal to qx by 4 pi E0 r cube. So make this observation before you plot the graph, that E is proportional to x. The graph will be a straight line passing through origin. Let us do another case when r is very smaller than x. That is far away from the ring when you are going to calculate strength of electric field. In that case, r square plus x square will be approximately equal to what? X square. So E going to be what? For this case, it is qx by 4 pi 0 x cube. X squared to the power 3 by 2, that is x cube. So q by, you have seen this expression before, no? This expression you have seen. Where? This expression is the expression for strength of electric field due to a point charge, isn't it? E equal to, so far away from the ring, if you go, then it will behave like a point charge. The strength of electric field given by this, and the graph we can plot accordingly. We have the experience of plotting this graph before. Now the question is, once you said in this observation that E proportional to x, now we are saying that E proportional to 1 by x square. The question is, up to what maximum distance it can happen, that where it is changing directly proportional to x, up to what distance it happens, and then its value starts reducing, that E proportional to 1 by x square. So we need to use little bit of calculus. We need to take the help of calculus, maximum or minimum on it. Up to what distance this straight line behavior of the field is observed, and then when it will reduce by obeying this law. Just let me remind you one thing from calculus, that maxima and minima. A function y equal to fx has maximum at a point if for maxima or minimum also can occur, for maxima or minima, that dy by dx equal to 0, and at the point of maximum dy by dx changes its sign. That dy by dx, if a function has maximum at a point here, at this point, dy by dx changes its sign. How does it change its sign? Dy by dx, it changes its sign like this. Before the point of maximum you reach, that dy by dx, it has positive slope, and after reaching the point, the dy by dx has negative slope. So what is happening at the point of maximum? At this point, x equal to a, say it has maximum value. How? That at the point of maximum, dy by dx changes sign from positive, it is positive slope, theta is acute, so positive slope to negative slope. At maxima, dy by dx changes sign, dy by dx changes its sign from positive on the left to negative on the right. Okay, dy by dx changes its sign from positive on the left to negative on the right. It will have maximum. Minimum in which case? Just opposite. In case of minima, if you plot the graph of function which has minimum value at a point, then at this point say it has minimum. Then at the point of minimum, dy by dx, if you draw tangent here, that dy by dx, it has acute value over there. Obtuse angle. So dy by dx here negative, dy by dx less than 0, just before that point. And after this point, dy by dx is greater than 0. Okay, here dy by dx greater than 0. So for minima, what happens? For minimum at a point, say this point B, for minimum at x equal to B, dy by dx changes its sign. Its sign from, this is obtuse, so tan theta negative, from negative on the left, say this is left side and this is right side, negative on the left to positive on the right. Okay, dy by dx changes its sign from negative on the left to positive on the right. Now let us go back to this sum where we are plotting the graph, where we have claimed that by actual calculation, of course, that E proportional to x up to certain distance increases. No negative sign is there, its value increases. And this one decreasing, at which point it has maximum value. Increasing, no, increasing, then decreasing. So there is a maximum value. We have to find it by using the concept of maxima and minima. So here the strength of electric field will be referring the expression already got, that E equal to qx by 4 pi E0 r square plus x square to the power 3 by 2. So for this E is maximum or minimum if dE by dx equal to 0. This implies, what is dE dx? Let us calculate. That is q by 4 pi E0 outside. Hope all of you remember the differentiation of this portion. This is r square plus x square to the power 3 by 2 whole square. This into derivative of this to the power 3 by 2 into 1 minus x into its derivative 3 by 2 r square plus x square to the power half into 2x. Okay, this derivative we did by quotient rule. So for maximum or minimum, this part going to be equal to 0. This implies q by 4 pi E0, this is derivative of the function, and we are comparing it to 0. This portion r square plus x square to the power half can be taken common. So what is remaining over there? R square plus x square, 2 get cancelled. This is common. It is minus 3x square equal to 0. Okay. So this is the result of dE by dx. I am writing once more here that dE by dx is q by 4 pi 0 r square plus x square to the power 3.5 5 by 2 into r square minus 2x square. See, this portion can never be equal to 0. This portion can be equal to 0 because r square minus 2x square equal to 0. So this implies r square minus 2, this is equal to 0 implies r square minus 2x square equal to 0. So x square is r square by 2. So x is plus minus r by root 2. Both are valid. What plus, what minus? On the right hand side of the ring, on the RHS of the ring, x increasing, x positive, better to say, and here x is negative, isn't it? So here x is x positive on the right side. So the graph will appear in both the cases, x will be plus minus r by root. So let us see whether this portion, this value of x gives maximum or minimum value of this function. So this dE by dx, if you rewrite, then you will observe that it is q by 4 pi 0 r square plus x square to the power 5 by 2, and they take 2 as common, or you take minus as common, then it is coming x square minus r square by 2. So it is minus 2q by 4 pi 0 r square plus x square to the power 5 by 2, then x plus r by root 2, x minus r by root 2. You understand? Now take these 2 points on the number line. Number line contains these 2 points minus r by root 2, and here it is r by root 2. See, sign of dE by dx changing, negative sign before. So dE by dx on right side of r by root 2, if you take any value larger than r by root 2, this expression is becoming negative. Am I correct? You take any expression larger than r by root 2, then this is positive, this portion negative. So this is going to be negative over there, minus, minus, minus. You take a value in between these two, then this part will be negative, this part will be positive, but here negative sign is there. So in between anything you take here, sign of dE by dx positive, and beyond minus r by root 2, this is negative, product is positive, outside negative. So less than minus r by root 2, it is negative. So what do you observe? At the point r by root 2, it has maximum value. At the point minus r by root 2, it has maximum value. Isn't it? dy by dx. No, this minus r by root 2, right now I will remain silent. We are drawing when x increasing first. Okay? Then x decreasing part will do. I mean x along negative x axis will do. First consider this part. It has maximum value at r by root. So I remind you all those cases we have considered for the electric field on the axis of charged circular ring. E is, let me write here, E proportional to x when x is small. X is much smaller than r. E is proportional to 1 by x square when x is much larger than r. And just we have observed maximum occurs here. So this information is enough to draw the graph here. Okay. So this is your x-axis. This is y-axis. Up to what distance? R is there somewhere, but r by root 2 smaller than that. Okay. So till r by root 2, its value goes on increasing. Okay. Till r by root 2, the value increases. As per this relation, E is proportional to x, this part. This is up to what distance? Up to r by root 2. After this, its value decreases. This graph we have seen before. It is inversely proportional to square of distance of separation. Value decreases gradually like this. Goes on decreasing. Meet x-axis. Meet at infinity. So this is the graph of E versus x due to a charged circular ring. I hope the topic is clear to you. You all have understood.